Alright, today I'm going to show you how to rotate your WireGuard keys. Specifically, I'm going to cover what are WireGuard keys and how are they used, why you would rotate your WireGuard keys, how do you rotate your WireGuard keys in general, and how do you rotate WireGuard keys specifically with Pro Custodibus. So first, let's take a look at a conceptual diagram of a simple WireGuard network here. We've got peer A in purple, peer B in brown, and both are connected to peer C in blue. Now each pair has a cryptographic key pair that both identifies the peer uniquely and allows the peer to establish an encrypted tunnel with other peers. And each key pair is comprised of two parts, a public key and a private key. Now you keep this private key secret and configure just the peer's own local interface with the private key, but you configure the WireGuard interface of every other peer with the public key. So in order for peer C and peer A to communicate, you have to configure the local interface on peer A with peer C's public key and the local interface on peer C with peer A's public key. And same thing for peer B and peer C to communicate. You have to configure the local interface on peer B with peer C's public key and the local interface on peer C with peer B's public key. So you share the public key with other peers, but you keep the private key secret. Keeping the private key secret is what prevents any other party from decrypting the traffic sent through a WireGuard tunnel. But notice you share the same public key with every peer to which a given peer can connect. So the local interface on both peer A and peer B is configured to connect to peer C using that same public key. Now if you want the same computer to be able to use different identities with different WireGuard networks, you'd set up that computer or host with multiple WireGuard interfaces, and you'd configure each WireGuard interface on that host with a different peer identity. So for all peer C nodes, peer A and peer B both could be residing on the same physical host, but just using separate WireGuard interfaces on that host. Now you can also add a symmetric pre-shared key to each individual connection between two peers. So for the individual connection between peer A and peer C, we've added a secret pre-shared key between the two hosts, which can further strengthen the security of the encrypted tunnel between peer C and peer A. It's because it's a shared secret, and you configure the local interface on both sides of the connection with the same secret key. In this case, we've configured peer C with this pre-shared key YYY123 blah blah blah, and we've configured the local interface on peer A with that same pre-shared key YYY123 blah blah blah. And we can do the same with other connections using a different pre-shared key, because a pre-shared key only strengthens the security of a connection as long as it stays secret between the two peers that share it. So you want to make sure that that pre-shared key is known only to two specific peers. So for the connection between peer C and peer B, we can configure the local interface of peer C with a different pre-shared key, ZZZ123 blah blah blah, and configure the local interface of peer B with that same pre-shared key, ZZZ123 blah blah blah. Now why would you want to add this pre-shared key to a connection? Well, you don't have to, because as long as you keep the private key of each peer secret, you'll be fine, because there are no known practical attacks against the crypto system used by WireGuard. However, WireGuard key pairs are generated using elliptic curve cryptography, so it may be possible in the future for a quantum computer to calculate the private key of a WireGuard key pair just by knowing its public key. So that would enable the entity using that quantum computer to decrypt any encrypted WireGuard traffic that it had previously captured and stored. So to hedge against that possibility is one reason why you might add a pre-shared key to each of your connections. And another reason why you might do that is to allow you to rotate your keys on a connection by connection basis, because you can rotate the pre-shared key of a connection individually without having to update all the other peers that can connect to a peer. So we can rotate the pre-shared key used by peer A and peer C without affecting the connection between peer B and peer C. Whereas if we rotate this peer C key pair, we have to update all the other connections that connect to peer C all at the same time. Now, why would you rotate keys with WireGuard in general? Well, basically there are two reasons. The first reason is when you know that somebody unauthorized has had access to a private key of a peer or to the pre-share key used by one of its connections. In that case, you would definitely want to rotate that key. And this could be something as dramatic as if you have been hacked by a sophisticated nation-state actor and you have evidence that that hacker accessed a particular machine. Well, then you should definitely rotate all the keys on that machine. But it can also be something as pedestrian as someone that accidentally copied their WireGuard keys into a shared folder, and in that case, you'd probably also want to rotate those keys. And it could also be the case when an employee leaves your company or moves to a different role or team within your company. You probably also want to rotate all the keys that that person had access to in their previous role. Now, the second reason why you'd want to rotate your WireGuard keys is when you don't know that someone has had unauthorized access to those keys, because you're still probably going to want to rotate them anyway on a regular basis just in case someone did. For example, if you're actually hacked by a sophisticated nation-state actor, you might not ever find evidence that they accessed a particular machine, or you might not find out for years or months later. Or if an employee accidentally copied their WireGuard keys into a shared folder, you might not ever find out about it, but someone else might have noticed and stashed those keys away for their own unauthorized use later. So it's a good practice to rotate both your public key pairs and your pre-shared keys on a regular basis. You know, something like maybe monthly for your pre-shared keys, yearly for your key pairs. A big good place to start if you don't already have a predefined key rotation policy that includes your WireGuard keys. And so that way, if, for example, an attacker managed to surreptitiously steal the private key and all the pre-shared keys used by a WireGuard interfaced on one host, and you rotated all those pre-shared keys on a monthly basis, that attacker would only be able to use the stolen keys to decrypt WireGuard traffic or to impersonate the host connected to those peers for at most 1 month. And if 1 month sounds too long for you, then rotating your pre-shared keys more often, like on a weekly basis, might be better. So that's why you would rotate your WireGuard keys. Now let's walk through the process conceptually. First, let's rotate the key pair used by peer C in this diagram, and then we'll rotate the pre-shared key used by the connection between peer A and peer C. So if we rotate peer C, which originally this old key pair, the public key was CCC123 blah blah blah. So let's rotate that and change it so that the new key pair of peer C has the public key being CDE 456 blah 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 and a new corresponding private key. So we've changed the private key used by this local interface on this host, but peer A and peer C are still using the old public key CCC123 blah blah blah. So we've just broken the connection between peer C and peer B and the connection between peer A and peer C. So the next step is to fix this. So on peer A, we'll configure its local interface with the new public key for peer C, CDE 456, blah, blah, blah. So once we do that, now peer A and peer C can communicate again just like they could before we rotated peer C. But the connection between peer B and peer C is still broken because we're still using that old public key of CCC 123. So we'll go and do the same thing on peer B. On peer B, we'll configure its local interface to use the new public key for peer C, CDE 446, blah, blah. And that will fix the communication between peer B and peer C, allowing them to communicate as they had before. So that's the process of rotating a public key pair for one peer. You have to update that interface used by the peer with the new private key for the peer, and then go through and update every other peer that can connect to that rotated peer with its new public key. Now let's take a look at the process for rotating the pre-shared key used by an individual connection between two peers. So if we want to rotate the pre-shared key used by the connection between peer A and peer C, which was YYY123 blah blah blah, we'd first go and update that pre-shared key on the local interface of one side of the connection on peer C here, so that to update it to use a different pre-shared key, in this case XXX456 blah blah blah. And when we do that, now we've broken the connection between peer C and peer A, because peer C has one pre-shared key and peer A has a different pre-shared key. So we have to go and fix the peer A side and configure peer A with that same pre-shared key of XXX456 blah blah blah. And once we do that, then the connection between peer A and peer C will be back up again, and we can use it just like it was before we rotated the pre-shared key. So that's the process for rotating the pre-shared key of one connection. You just update the local interface on both sides of the connection with that new pre-shared key. And you'll note that when we did that, we didn't have to do anything to peer B. So our change to the connection between peer A and peer C didn't affect the change between the connection between peer B and peer C. So that's why it can be more attractive if you do regular WireGuard key rotations to just rotate your pre-shared keys instead of all your key pairs, because with your pre-shared keys you only have to coordinate the change between the two sides of each connection instead of coordinating among every other peer that can connect to the rotated peer. So now let's take a look at how you do this with ProCustodibus. Now we've actually got a dedicated tool on ProCustodibus for rotating keys that makes it pretty much one-click process. So say for example we want to rotate the public key pair for the CI box, and in particular the peer used by the WG dev interface. I would go into the main page for this CI dev peer, and I'm going to click the Manage Key Pair icon in its peer panel. And so from this page we can see the details of the key pair and also the list of connections from the CI dev peer to each other peer that can connect to it. So the left hand side of this table shows the places where this peer is used as the identity of the local WireGuard interface, which in this case is just the WG dev interface of the CI box. And then on the right hand side of this table I can see all the other peers that can connect to this CI dev peer. And you'll note that on the right hand side of the table we do have one blank line. So all these other hosts, we have the ProCustodibus agent running on it, so ProCustodibus has access to the configuration on all these other hosts. But on the mail server, we don't have the ProCustodibus agent on it, running on it. So ProCustodibus doesn't have access to the mail server's local configuration. So when we rotate this key pair, ProCustodibus will be able to rotate the key pair on the CI box, as well as all these other hosts that do have the ProCustodibus agent running on it, except for the mail server, which doesn't have the ProCustodibus agent running on it. So we'll have to update the mail server manually with the new key pair. But for everything else, all I have to do is just click this rotate key pair button, and that will bring up a confirmation dialog, and I'll have a link to our key pair rotation documentation in case I need some help updating the mail server manually. But now when I click the OK button, ProCustodibus will go ahead and queue changes for all these monitored hosts to rotate the key pair. And so ProCustodibus has created a new key pair for us, new public key and private key, and has queued a bunch of changes. One, to update the local configuration on the CI box with a new private key, and then a bunch others to update the configuration of these other hosts with the public key of this new key pair. And now it might take a couple of minutes before each individual host downloads the queued change for it and executes it. So there might be a minute or two of downtime for some of these connections between the time when the CI box is updated with the new private key and each of these other individual computers are updated with the corresponding public key change. So make sure you do this at a time of day when you can afford to have a minute or two of downtime. And while we're waiting, let's go and find the old version of this peer identity. So we can go to click the peers link in the page breadcrumbs, and we'll see the list of all the peers that have been used by this organization, and we can see that we've got this new CI dev identity as well as the old peer identity that we just rotated. So I can drill into this old CI peer identity, and I can see and copy the old public key used by this old identity and see the old historical usage of this identity. But let's go back to the new CI dev manage key pair page and see that we have executed all the changes that we were waiting for. So let's go in and look at the local side of this CI dev box, the configuration for this interface, and we can see in our changelog that we've changed the peer identity used by this interface from the old identity to the new one. And if we go back to that manage key pair page, we can also drill into one of these remote sides of the connection, look at Adam's laptop, and we'll see that on Adam's laptop we've got our new connection to the new CI dev identity created, and the old connection to the old CI dev identity has been deleted. So his connection to the CI box has been updated, and he's now able to use to connect to it using its new public key pair. And now what about the mail server? So all these other ProCustodibus is taking care of all these other connections for us. What about this mail server connection? Because we don't have the ProCustodibus agent running on the mail server, we'll have to update its side of the connection manually. and it's actually managed by a different team. So what I'm going to do is just copy the new public key that's been updated on the CI box, and I'll go and send that to the maintainer of this mail server, and then they'll need to update their WireGuard configuration to use this public key for the connection on their side to the CI box. And once they make that update, then the CI box will be able to send emails again over this WireGuard connection. So that's how you rotate WireGuard key pairs with ProCustodibus. Now let's take a look at how you rotate pre-shared keys. And the process is actually pretty similar. Let's go back to the host page and let's rotate the pre-shared keys for our ticket server. And just like on the CI server, I'm going to drill into the interface used by this ticket server and drill into the main page used by this ticketing peer. And instead of clicking on the Manage Key Pair icon on the Peers panel, I'm going to click on the Manage Pre-Shared Keys icon. And again, you see a similar table to the Manage Key Pair page listing each connection between this ticketing peer and all the other peers that can connect to it. And on the left-hand side, we see the configuration of each connection on the ticketing peer side, where the ticketing peer is used as the local identity of the WG interface of the tickets host. And on the right hand side, we can see all the peers that can connect to it and the configuration for the peers that are managed by the ProCustodibus agent. And we also have a couple blanks on this right hand side where some of these peers that are connected to the tickets host don't have a ProCustodibus agent running on them. So Dylan's laptop and Jen's laptop and the mail server again and Vikram's laptop, they all don't have the ProCustodibus agent running on them. So if we rotate the pre-shared key for this connection, say with Dylan's laptop, we'd be able to do it. ProCustodibus would do it automatically for us on the ticket side of the connection, but not on Dylan's laptop side of the connection. So I'd have to coordinate with him to get him to also update his laptop. So what I'm going to do for now is just rotate the pre-shared keys for the connections where we have the ProCustodibus agent on both sides of the connection. And I'm also going to do the mail server as well, and we'll handle the mail server manually again, just like we did with the key pair rotation. So I've selected all these connections, and then I'm going to, one thing I also want to mention is that we have an asterisk next to the endpoint of each connection that is currently using a pre-shared key. So all these connections actually do already have a pre-shared key. We're just going to rotate that existing pre-shared key for each connection to use a different pre-shared key. And so I'm going to click the Rotate Pre-Shared Keys button, and this brings up a confirmation dialog and a link to the key rotation document for pre-shared keys in case you need some help manually updating this mail server. But for all these other selected connections, when I click this OK button, ProCustodibus is going to generate a new random pre-shared key for each one of those connections. And it's going to queue a change on both sides of those connections. So for the connection between the tickets host and the VCS host, because we've got the ProCustodibus agent running on both sides of the connection, ProCustodibus will queue a change for the tickets host to update the pre-shared key for this connection between the tickets host and the VCS host. And it's also going to do the same thing on the VCS host to update the pre-shared key for this connection on both sides with the same new pre-shared key. And just like with the key pair rotation, it might take a minute or two for each of these hosts to download the queue change and apply it. And so there may be a bit of time, a minute or two, during which one host has downloaded the update to its connection, and the corresponding host hasn't updated that that hasn't made that update, and so during that time, that connection between those two hosts might be down. So just like with key pair rotation, make sure you do this at a time of day when you can afford to have a minute or two of downtime. So let's drill into one of these connections. Let's look at the connection between Adam's laptop and the ticketing server first on the ticketing server side of the connection to Adam's laptop. And we can see that we've just made that change to update the pre-shared key, and we're displaying in the change log actually the hash of the old pre-shared key and the hash of the new pre-shared key. And so if you want to see the actual pre-shared secret, you can click on the Manage Pre-Shared Key icon, that pre-shared key panel, and you'll see the actual new secret pre-shared key between Adam's laptop and the tickets server. Everywhere else in the Pro Custodibus UI, we're just going to show the SHA-256 hash. So we aren't going to show the actual secret except on this one particular page. But you can still use this SHA-256 hash to verify that we're using the same pre-shared key on each side of the connection. So on this ticketing side of the connection, the ticketing connection to Adam's laptop is using this new pre-shared key with a hash of 3A5Y, and if we look on the other side of the connection, the corresponding endpoint on Adam's laptop connected to the ticketing server, we see that we can verify that we're using the same pre-shared key because it's got the same SHA-256 hash for that key. We've also made that change to update the old pre-shared key on Adam's laptop with the new pre-shared key. So both sides of the connection, Adam's laptop and the ticketing server, both have been updated to use this new pre-shared key. And it's going to be the same thing for all these other connections that we've updated except for the mail server, because again, we only have the ProCustodibus agent running on the ticketing side of the connection and not on the mail server side of the connection. So the last thing we need to do here is drill into the mail server endpoint on the ticketing host here and drill into the Manage Key page from the Manage Key icon in the pre-shared key panel and copy this secret key that we've updated on the ticketing side of the connection to the mail server, and I need to send this securely to the team that manages the mail server so that they can update it on their side of the connection, and once they've made the update in their WireGuard configuration on the mail server, then the ticketing server will be able to connect to the mail server again through WireGuard and be able to send email out through that. So that is how you update pre-shared keys with Pro Custodibus, and that is what I wanted to show off to you today: the what, why, and how you rotate WireGuard keys and how Pro Custodibus makes it easy.